Dobar dan svima, and thank you for joining this short and compact presentation about graph technology. How many of you are using graph now? Oh, almost no one. So let's start from the beginning. What is graph? Not this. So we're not going to talk about this kind of graph, but we're going to talk about graph, which is a sort of new technology from technology perspective, but it is actually older than a relational system. Why this? Because it's based on a mathematics, so it's based on a graph theorem, which is very old, so it's back in 18th century. And you know, relational database started somewhere end of 60s. So what is actually a graph? It has, or it consists of two objects. We have the dots that you see here called nodes or vertices, and the connections in between are called edges. So it is very natural, let's say, the natural storage model for store the data. And what is also very important here, you can actually have attributes connected to the links or these connections itself. And this is the model which, or the graph schema is a model which describes the types of vertices and edges and how they are connected. And what is a relation here in this case? It is a verb or action that connects two entities. And what you see in a lower corner here, it's the smallest graph that you can have. So it consists of one simple node with a simple connection to itself. So it's a self-join, let's say, type of connection that you will maybe have in a relational system. I would say graph is not only very relational. Basically, for me, graph is the relational database model. So why this? Because a relation is an entity for itself. Here, it's just a presentation how you can compare a graph schema on the right side with a relational database schema on the left side. What is actually here the biggest difference? So one of the differences is that this foreign key connection is always saved in a one or other table. So if you do some updates, if you do any changes in a table, you are touching the connection itself. Doing this in a graph model, it's not necessarily changing the system of the connections. You can update the object itself, but the link would still be there, and you don't have to touch it itself. When we talk about graph databases, we differentiate between those, let's say, two big models. On one side, semantic or RDF graphs, and the property graphs. So semantic is a model which exists for a long time. It's based on subject, object, and predicate. That's why it's this triple. It is always pattern matching, and it's a logical interface. What we have on a right side is a property graph. So this property graph has basically those objects that are separated, so nodes and edges. It has a higher performance for everything. Why this? Because to find a connection, you don't have to search through those triples. And it's mostly schema-free or schema-based. And of course, you can actually use the schema changes to tune up your application, like you would do in a relational database model. Adding an index, for instance, is doing the would allow you the tuning of the system. Then we have Basically, those semantic or property graphs can be transactional or analytics. And what is TigerGraph? This is the company that I represent. We are basically in the middle because we have a transactional analytics part. So TigerGraph itself, if we're talking now of TigerGraph, it's not a graph database, it's a graph analytics system. So it is actually it's an analytics system based on a graph database. And what can, in this case, TigerGraph can do for you? You see some examples how the data can be organized better than you can actually do this in a relational database. So the first, let's start with a upper left corner. So with this first example, which is deep link analysis. This is the ability to efficiently and programmatically traverse a graph. So when we search in a graph database, we traverse. We are following the path for, let's say, 3 or more hops, which would be 3 or more joins in a relational database, and then analyze this data that we collect in a traversing. And in this case, you can go 10, 16, 25 levels deep if you want. And the more the hops you have in a traversing, the more insight you're going to get of your data. But it's also, of course, harder to manage because the number of connections that you have would grow exponentially. So this could be used for, let's say, fraud detection, for anti-money laundering, recommendation engine solution. One of the benefits here is you can do lots of things using graph database in real time. So if you go, let's say, 5 or 6 or 7 level deep, it would be probably real time. So for fraud detection, it is easy to implement something like this where you get the answer very, very fast. So the next one would be pattern matching, I think. Yeah. So what is a pattern matching? It's basically not based on a pattern matching that you know from a relational database. We are not matching the text. What we are matching is the way the connections are done. So the objects are connected. So this enables you to find, for instance, customers who would like to buy some next product based on somebody who already did something like this. You can also find people that would actually, or let's say, find connections that would match positively or negatively to enable this, let's say, better computation of your data. Then we have this relational commonality discovery computation, which is, let's say, we have two entities, in this case A and B, and we would like to find what is the similarity between them. We have here multiple ways to do this similarity matching. In an example in demo that I'm going to show you later on, you will see how easy it is to implement something like this. So you can use this for instance, to find common members between patients and doctors in the health industry, or some common connections between customers if you're using e-commerce and so on and so on. Or let's say if you're using banking services, if you're a big financial service, you can use this to find similar customers and propose maybe different services for those customers. What is also very graphy way of analytics is hub, or this community detection. So here you can find most influential members of a community, and of course it can be used as something like Instagram, but in a real case or in real life you can use it for insurance fraud, finding let's say syndicates crashing cars, and this is always a group of people doing this. So if you do just one let's say, one-level approach on top of claims, you would not be able to find this community. But if you go deep and analyze the connections between the people, and in this case, this is a real life case, with insurance, there are people in this community, or let's say in this syndicate, acting as a driver. In a second case, they would be a witness. In a third case, they would be maybe injured, and so on and so on. And graph system is getting all this data together. So we have a big insurance working with this system. It is very easy to find out, let's say, the group of people, and then somebody who is taking care of these claims can check if this is irrelevant or not. But this is something that you can do only with the graph system. So, and then there are some other use cases like GeoGraph analysis, time series, or machine learning. And machine learning here is very important for, especially in TigerGraph case, because TigerGraph allows you as a user to use machine learning in database. So it's very fast, and your data is not leaving the system. So let's just be a little bit, we have a few minutes just to talk about what is TigerGraph, then I'm going to show you the demo. So this is a normal architecture of a TigerGraph. It's a system that can be run on as a single machine system, but if you need more data, if you need more power, you can distribute the data, and you can make a nice cluster of machines. So there is no limit, actually, what you can do with TigerGraph. On one side, you can import the data on various ways. On the other side, you will probably use REST API to consume the data as a JSON or CSV format. And what is specific for TigerGraph in this case is a Graph SQL. So GSQL is our language for query the data. It's a Turing-complete language, so it is a declarative and imperative programming language. You can compare it with a SQL plus store procedure. So basically, you can do both here in this system, and the whole computing is done in the background on the server. It's very easy to learn. It is not SQL language, it's SQL-like. It's compiled in the background to optimize the performance. So you can use many libraries, like in this case, PageRank, community detection, or similarity for, let's say, as an open source. We have the flow statements, of course. We have mathematical functions on it, and makes in database machine learning possible. How does it look like? It's basically create a function here. There is a data declaration block, and there is a query logic block. So in this case, and I can show you then later on what it's actually doing, it is taking the movie title, going from this movie title and start traversing over different links and printing the results. And one of the specific property of TigerGraph here is UDF. So you can actually write your UDFs using C++, compile it, and just use it as a GSQL, let's say, function. So this will be the part of the short demo. And I hope that you can see now my screen. So basically, this is a developer view on the database. So it's called Graph Studio. Just move it a little bit bigger. This is the schema that I prepared for this presentation. The schema itself is based on IMDb database. So what I did here, I took the IMDb database, which was in a relational database format, convert this into graph schema, and did some data mapping. In this case, the data mapping is done like, let's check it. I think we have something like this. So basically, we have on one side the CSV file, on the other side is the matching for for this, but it's not complete here, I see. So basically, this is how to load the data. And then, this is a cloud instance that was prepared for this presentation. So I have something like 19 millions of vertices, 156 millions of edges, connections in between. And you see there are 11,000 names. We have something like, I don't know, this is edges. Let's see the titles, and 8.1 million titles or movies. So what we can do here is do some, let's say, I can go and search for a name. And this would be Joža Horvat for the people who knows him. We can do, I'm lazy, so I actually prepared something here. Let's do a second one. And we have a second one is Boris Dvornik. So let's do this. So we have, okay, it's not a name, it's a title. Now I have, basically, this is Kapetan Mikula Mali. Since we are in Dalmatia, I think it's a good choice. So what we can do now is I can go and double-click on this and do just a little bit force the screen, and then I will see it's the properties. It's a drama, so if I move a bit in, it's also war drama. It was made in 1974. So, and now I have some actors. So Zdenka Novotny was acting here. And then Nikita Kalodjera was principal, so he was composer. You see the job category. Then you have Branko Gretic, and so on and so on. So this is the, and this person was actually, Tonči Vidan had similar, he was not only having, let's say, a simple single role, but he had a role of Dječak here, and he was an actor. And okay, we know that it was a movie. It was what else? What else is interesting? So basically, those are all the data that I have from this movie. So if I would like to see what was Tonči doing, I can double-click on it, and I can traverse again, and I would see he was actually acting in Borbeni Zadatak. I don't know, you can see this good, or should I? Okay. Robinsoni, Nenadan Susret, Kapetan Mikula Mali, Klopka, and so on and so on. Zbieg. So basically, I can do this for any of those people and see actually the connections. So this is very, I would say, unusual way to traverse through data, because you have to click and you have to check the data manually. So one way to do this would be to write the, this query, what I showed you before. The other way would be to, let's say, check some connections. So what is also Graph Database offering is to find connections that you're not aware of. So in a relational database system, you would write a query which is actually asking for the question you already know the answer, but you not know the data. In this case, you are not sure about the answer. You don't know what you're looking for. So let's try to do this. Let's do the title. And let's try to, I'm sure that Boris Dvornik had something to do with this movie. I'm not sure. So I have those two items. So Boris Dvornik and this movie. So what I could do is I can go and try to find parts between them. And I can say, show one shortest part, all shortest parts, and shortest part means everything up to 6 steps from this. What I'm going to do is also, I'm not going to use title type, title genre, or title rating, because those connections are too, I would say, not important. Because if he was acting in a war movie and he was acting in 30 war movies, I don't care. I know that this was a war movie and he was acting in them. So this is what I want to avoid. So if I click on Find Paths, it may take a little bit. Why is this here? I was very cheap, so I took one of the smallest cloud instances that we have. So it's not very fast, but it could be actually faster. So I see that he was worked as a writer for both movies. He was actually, no, he was working as a writer together with Joža Horvat. But this was actually wrong. I would like to have the connection between those two. So let's see, I have this one and take the movie. So it's a TT 0071711. And now find paths. Let's see what is going to happen. So I know that Boris Dvornik and Joža Horvat were working as writers, but I would like to know what is the connection between Boris Dvornik and this movie, Kapetan Mikula Mali. So this is not pre-compiled. This is working on this, let's say, the whole full database stack that we prepared for here. And it should be done. So we got everything. So let's analyze this a little bit. So I see on this side Kapetan Mikula Mali. I see on this side Boris Dvornik. And now we can actually go in and check the connections. So I see that this guy was connecting actually lots of things, because he was director with this guy here, with Obrat Gluščević, and it was Čovjek od Cvita. So Boris Dvornik was acting here in Čovjek od Cvita. He was having a role of Ivo, and with this guy, and they're connecting over this director, and over this guy, and over this movie, which is, in this case, the Dervish and the Dervish Ismet. So it is just basically a very easy way of getting the connections in between. So, of course, we could do this on a multiple ways. So I could actually select more than 1, 2, 3 connections and do, let's say, something like this, and then find connections path if I would like to. But what I would like to show you, and I know that you all would like to have the break, is just to do some queries here. So let's start with a very simple query: what happened in year? So if I run it, and let's start with the year, I don't know, 1981. Run query. So I was traversing now this database, and if I see actually my connections or how the database is done, I used the years, start in year, end year, birth year, and dead year. So I just said, check everything what is connected with this year. And this is the result. So I have 8,600 births. I have 1,800 deaths. I have 513 movies were ended in this year, and 30,000 something movies were started in this year. Or what we also could do is, let's do one hop from a movie and just click here, run query. So these are my, let's say, one hop of the data. The data what I would get would be in this JSON format. So how do you consume the data? You click basically on this link, and this is the URL for REST API knot that you can ask. You will use title ID like I did it here with TT something, and yeah. Da vidim, ali. Samo da go. Okay. Okay. We have a few minutes, so I think it's annoying, but you will understand. So this is basically how you call the system. Or I actually told you that I'm going to do some similarity search. So what we did now was a search for, let's say, something that we know that the connections are there. So let's take this one. This is the find similar movie. I would like to have this movie, and I would like to find 10 similar movie based on the movie that I selected. And now, this is the movie that I was looking for. It was Kapetan Mikula Mali. This is Vuk Samotnjak. This is Didino Dite. Okay, this is probably the episode, something like this. Klopka, Borbeni zadatak, Topović Svrci, Nenadan susret. So this was not a similarity search like find all the movies that has something, let's say, in common with a title. It is based on the structure that we have here. So it is based, actually, it analyzes the title, it analyzes the people who are acting, working for the movie, analyze genres, ratings, and everything else, and giving this as a result. There is a intersection of it, and you will get this, if you want this in a visual format. We are going to show you tomorrow in a workshop how to embed the data in your web graphic user interface. And just to, I would say, to finish, let's do this with a persona. So it's the same Jacquard similarity, which is not the perfect. Why this? Because I'm looking over all the edges. So I'm traversing everything, which makes no sense sometimes. In this case, with a year. But let's try this. And now, let's see what we got. So I have this is Boris Dvornik, Pero Gotovac, Miljenko Smoje, Blaženka Jencik, Daniel Marušić, Zdravka Krstulović, Karlo Bulić, and so on and so on. So you see people that are somehow connected to Boris Dvornik, even if you don't know how. So this would be a part of a demo. And let's go a step further. How to start with TigerGraph. So you can join us after this talk with a beer. We have a cool cold beer. It's a local one. It's from Čakovec Brewery. So come to us and talk to us, and visit our TigerGraph workshop for developers tomorrow. It would be starting 11:35. It's a workshop 2, I think. Our colleagues from Hive are going to present how to integrate TigerGraph using Vue.js and Quasar. And there are some TigerGraph resources in case you are going to download this presentation that I would like to share with you. So TigerGraph is an American company, relatively young. The product is really young. It is end of 2018, so it's not known, but we are very expanding very, very fast. And this is it. Thank you very much. If you have questions, you know where to find us.